Hello everyone. Let's kick things off with the basics. How do we identify hydrogen gas? Hydrogen is one of the most fascinating gases out there. It's colorless, odorless, and lighter than air, which means it rises quickly in the atmosphere. In fact, being the lightest known gas, it doesn't hang around for long, it escapes into the upper atmosphere. Even though hydrogen is non toxic, it's highly inflammable, which makes it both a useful and dangerous substance. Interestingly, hydrogen doesn't support respiration or the combustion of other substances, unlike oxygen. If you've ever wondered why hydrogen isn't found in large quantities on Earth, this is one of the reasons. Its low density causes it to escape into space. Now, let's talk about one of hydrogen's most exciting properties, its combustion. When pure hydrogen burns in air, it does so quietly with a pale blue flame. This is the reaction G plus O G O J. As you can see, hydrogen combines with oxygen to form water vapor, and that's it. It's an exothermic reaction, meaning it releases energy, and the only byproduct is water vapor, making hydrogen a very clean fuel. Isn't that amazing? No harmful pollutants, just pure water. This is why hydrogen is considered an environmentally friendly fuel. Imagine a world where burning fuel results in only water vapor. That's hydrogen for you. Now, let's move to one of the classic tests for hydrogen, the pop test. If you mix hydrogen with air and ignite it, you'll hear a distinct pop sound. This is due to the rapid combustion of the hydrogen gas in the air. It's a quick, explosive reaction that confirms the presence of hydrogen. Of course, the pop test can be dangerous, so it's crucial to conduct it carefully in the lab. This test is the go to method for confirming hydrogen. It's like a mini firework to test whether you've got the real deal. Hydrogen isn't just a lab curiosity, it has many practical uses in the real world. It's used as a fuel in applications like coal gas, water gas, and even liquid hydrogen. It's a key part of meteorological balloons, which are used to study weather conditions. But hydrogen's most exciting application is as a rocket propellant. Liquid hydrogen is used in rocket engines, providing an eco friendly and powerful thrust to send spacecraft into orbit. Although hydrogen used to fill weather balloons, it's now mostly replaced by helium due to hydrogen's flammability. Still, hydrogen remains a crucial and clean fuel in the world of energy. Hydrogen plays a starring role in the industrial world. One of its most important applications is in the synthesis of ammonia, a critical component in fertilizers, through the Haber process. The reaction is N plus G NH plus delta. This process requires high temperatures and pressures and a catalyst to work efficiently. Hydrogen is also used in the production of hydrogen chloride HCl through the reaction plus ClHCl. Interestingly, this reaction is slow in diffused light but becomes explosive in direct sunlight. Hydrogen also forms many other compounds. For example, when combined with oxygen, it forms water, and with sulfur, it forms hydrogen sulfide. So, hydrogen is not just useful in the lab, it's a vital raw material for the chemical industry. Now, let's take a deeper look at the energy content of hydrogen. We know hydrogen burns cleanly, but how much energy does it release? Let's calculate it step by step. The combustion of hydrogen has a heat of combustion of minus 286 kJ per mole. If we burn grams of hydrogen, we can calculate the energy released. First, we find the moles of hydrogen. Grams divided by grams per mole equals 1 mole. Then, we multiply by the heat of combustion. 1 mole times 286 kJ equals 286 kJ of energy. So, burning grams of hydrogen releases 286 kJ of energy. That's quite a bit for such a small amount of fuel. This high calorific value is one of the reasons why hydrogen is considered a top contender in the search for clean, high energy fuels. To sum it all up, hydrogen is a gas with unique properties that make it useful in both the laboratory and industrial settings. From its quiet combustion with water to its applications in fuel, weather balloons, and rocket propulsion, hydrogen's versatility is remarkable. In industry, it's essential for processes like ammonia production and hydrogen chloride synthesis, and its energy content is something to marvel at. Hydrogen is not only a laboratory reagent, but also a vital raw material in manufacturing and energy production. So, the next time you prepare hydrogen, keep in mind the conditions, reactivity series, and the best method for the job.